Every Edibon product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain, under several quality standards.
In this video, we will be discussing the proton exchange membrane fuel cell called the EC5C. This unit has been designed to give students a good understanding of fuel cell technology and to demonstrate how a PEM fuel cell generates electric power from hydrogen. With this fuel cell, students will be able to learn from exercises such as calculating fuel efficiency, power density, and much more.
This unit is supplied with a SCADA unit control system, which is patented by Edibon and based on LabVIEW. This unit includes the physical unit, a control interface box, a national data acquisition board, and a software package that allows computer control, data acquisition, and data management. The EC5C hydrogen fuel cell unit includes the main unit, a control interface box, and a load regulation system. All components are securely fastened to a frame made from anodized aluminum, which guarantees good stability and corrosion resistance. Let's take a closer look at the main components of the unit. They include a metal hydride bottle to store the hydrogen, a pressure regulator, a hydrogen leak detector, an inlet pressure regulator and flow sensor, a battery to start the interface and a converter and cables to charge the battery, a solenoid valve to supply the hydrogen, a pressure sensor, the fuel cell stack, temperature sensors, purge solenoid valve, and a cooling fan incorporated into the stack. The load unit regulates the load connected to the PEM fuel cell. Thus, the polarization curves of the PEM fuel cell can be studied, as well as the consumption of power generated by the cell observed. This load consists of a rheostat, which is manually regulated by means of a controller located on the unit's auxiliary box. All information from the unit passes through the interface box before going to the computer. On the front panel of the interface, we can find the on-off switch for the unit, temperature sensor inputs, flow sensor input, pressure sensor input, current sensor and voltage sensor input, security hydrogen detector light, and a light indicating that the fuel cell stack has started functioning. A unit diagram, which represents the distribution of the different components, is included on the main unit and on the front panel of the computer-controlled interface. Before we start using the unit, I will explain the layout of the user interface. The main controls are in the upper left corner. This includes the calibration, start, stop, view data, and quit button. A schematic diagram shows the layout of the components in the system. The sensors are located in the upper right. This includes temperature sensor for the fuel cell stack, temperature sensor for the purge flow, fan speed, flow sensor, inlet pressure sensor, power sensor, voltage sensor, and current sensor. In the lower right, we find a fan speed gauge. The interface can display two independent graphs or one large graph using the drop-down selection. Data can be graphed as a function of time, compared with other data on an X versus Y graph, or shown on a chart. The parameters that are displayed on the graph can be selected in the bottom left region.
After correctly setting up the unit, the first step in any exercise is to turn on the interface. Next, open the hydride canister slowly, allowing hydrogen to flow to the regulator. Using the Edibon SCADA system, you are able to control the unit using a projector or electronic whiteboard. To begin, open the unit control page. Press Start and choose a file name to save data and press OK.
Next, adjust the pressure regulator so that the inlet pressure to the stack reads 0.4 to 0.5 bar by the software. Now we are able to read the information from the sensors in the unit. As an example of a practical exercise, we will look at the graph of power versus current in the hydrogen fuel cell. First, select Single Graph. Choose the sensors to be plotted. Next, select the X versus Y graph. Select the parameters for the X and Y axes. The scale of the graph can be easily adjusted by simply typing in new numbers. Now press Save Data. You can adjust the time between data points by typing in a number here. The frequency of data points taken is indicated by a flashing light. For this exercise, set the frequency to 0 because we will be taking the data points manually using this button here.
Set the load by adjusting the rheostat on the load module.
You can see the sensor values changing. Wait until the current and power values stabilize. Then press Take Data to plot a point on the graph.
Adjust the rheostat again for a second data point.
Watch the power and current stabilize and press Take Data.
Finally, adjust the rheostat once more for a third data point.
Repeating the steps plots additional points on the graph. We now have a power versus current curve. We can also view the data on a chart. To finish the exercise, press Stop, which stops the unit. Press View Data to find the data saved in the computer. The user manual provides multiple practical exercises that walk the students through the correct operational procedure while teaching specific concepts. Only Edibon has a SCADA system that provides the following benefits: open control, multi-control, and real-time control. This means that at any time during an experiment, multiple parameters can be changed at the same time with instantaneous effects on the unit. Each unit has specialized software based on LabVIEW to enable easy control of the unit. Calibration exercises, which are included, teach the user how to calibrate a sensor and the importance of checking the accuracy of the sensor before taking measurements. Projector and electronic whiteboard compatibility allows a unit to be explained and demonstrated to an entire class at one time. The system is capable of being remotely controlled over the internet by the user or by an Edibon technical support engineer. Each unit has 4 safety systems that are designed to mitigate risks for the user. This unit has been designed for future expansion, such as incorporating the unit in an Edibon SCADA-net system, which enables many students to simultaneously operate any unit in their SCADA network. The following is included with every Edibon unit: 8 manuals, including a user manual that explains the scientific theory being studied, any related mathematical equations, the function of each component in the unit, and how the unit is operated. Each unit is designed and manufactured under strict quality control, which allows us to offer a 3-year guarantee against any manufacturing defect, and components control for the lifetime of the unit. Lastly, due to the previously stated points, Edibon proudly provides full customer satisfaction.